Obviously, I'm guaranteeing you now, you will see on the quiz, you will see the necessity of, given 2 points, either find the length, midpoint, or slope of the line connecting them. Or segment, excuse me, not the line. You'll probably have to do 2 of the 3, where you have to demonstrate your knowledge of the formulas. Now, given x and y, it says find xy. And some people get confused by that. What do you mean xy? xy, that goes back all the way back to chapter 1, means the length of segment xy. Which formula are we going to use to do that? Distance formula. So again, we do all steps. Do all steps. Start by setting up our form, then substitute our values in. The x's are -3 and 2. The y's are 7 and -1. Now, I know some people get upset. Wait a minute. You put the x1 first and the y. Doesn't x2 have to go first? It doesn't matter which one goes first, just as long as you're consistent once you make a decision. So I use the -3 first in this one. I have to use the 7 first in this one. Because I don't know if this is 0.1 and this is 0.2, or this is 0.1 and this is 0.2. I really don't know. It doesn't make a difference. The length is the same forward or backwards. Then we do our math and rewrite the problem. Don't be trying to do this all in your head and getting an answer. Rewrite each step. Because if you do make a mistake, I want to see where you make a mistake to see what you're doing wrong. This is -5 squared plus 8 squared. -5 squared is +25. So my distance is square root of 89. And that's not going to simplify. I'd simplify it if I could, but in this case it doesn't. So there's the length of that segment, square root of 89. That's how we do it. Showing your steps every way. Now, I still get a lot of people when I was working with some people, -5 squared is -25. A negative times a negative is a positive. That's something we learned a long time ago, but people have a tendency to forget that. It's -5 squared, not -5 squared. There's a difference. We always wind up adding numbers under here. So that's how that goes. Midpoint of xy. Again, set it up. The x's go here. The y's go here. And just do the arithmetic. -3 plus 2 is -1/2. 7 minus 1 is 6. 6/2 is 3. And it's a point, so it should be in parentheses. Because remember, a midpoint is a point. It is not a distance. It is not. We don't combine those terms. We don't do anything with it. It's xy coordinates of a point. That's what we're finding. Find the slope of xy, change in y over change in x. So 7 minus -1 over -3 minus 2. 8 over -5. Have you noticed, by the way, when we do slope, we get the same numbers here pretty much that we get there? It's no coincidence. We're doing the same math. Yeah.
Did you do it backwards?
Did I do the what? Y's on top?
Isn't it -1?
Doesn't matter. Like I said, it doesn't matter which one comes first and which one comes second as long as it's consistent. And here, I'll just show you. If we did -1 minus 7 over 2 minus 3, -2 minus 3, I'm sorry, what were the numbers again? 2 minus -3. If we did it that way, this becomes a positive. I get -8/5. That's the same value, right? It doesn't matter which one comes first. Just as we're consistent. Since the 7 was first here, the -3 had to be first down here. That is important that you're consistent. x's over y's or something like that. So anyway, that's going to be part of your test tomorrow. No doubt. Not lying. That's exactly the type of thing you need to know how to do. If you don't know how to do it, it's not because we haven't shown you how. It's not because we didn't tell you it's going to be on there. It's because you're not taking the time. Yeah. If the diagonals have the same midpoint, that means they bisect each other. Because diagonals bisect each other, it's one of the ways to prove something's a parallelogram. Given the shape as a parallelogram, solve for x and y. Pretty basic type of problems. How are we going to set the top one up? Okay, and that's pretty easy. Subtract the 2x, add the 5. Again, showing the work, I get x equals 12. How about for the y's? Yep. What are we going to do to both sides to solve this one? Subtract y. Yeah. Basic algebra. 2y equals 4, so divide by 2, y equals 2. How about down here? Given it's a parallelogram, (2x plus 1 equals 15), yep. So subtract the 1, 2x is 14, x is 7. How about for y's? 6y equals 18, and again, very basic. Y is 3. Different wording in the instructions, but the same idea. Give the values of x and y that make this a parallelogram. In order for it to be a parallelogram, the opposite angles have to be what? Congruent. Which means those measures have to be the same. They have to be equal. So 3y plus 48 equals 5y. So subtract the 3y. 48 equals 2y, so y is 24. And for x's, subtract the 2x, x equals 20. Okay. Some people say, well, couldn't I do the supplementary thing here? Well, I guess we could get 3y plus 48 plus 2x plus 20 is 180. Give me 5x, oh no, 5x, no, I can't combine that. What am I thinking? 3x, 3y plus 2x plus 68 equals 180. Or bring the 68 over, so 3x, 3y plus 2x equals, subtract 68, 112. And then you have to do a second equation over here, and you have to solve simultaneous equations, which is a lot more algebra. Could you get to the answer? Oh, yeah. But you really don't want to do that. You don't want to mix x's and y's in the same equation if you don't have to. We have the luxury here of just doing it in two quick equations with just one variable each. Then finally this is what's on the quiz form. Given ABCD, prove that, or given these points, prove it as a parallelogram. Now, some people are still having difficulty plotting points. So, one last time reviewing. This is the x-axis, this is the y-axis. Every point has coordinates x, then y. So when we're plotting the point, negative 3, 6, that means on the x-axis go negative 3. On the y-axis go up 6. Hold on. 1, 2, 3, 4, 5, 6. There we go. Okay, that's point A.
Can you do rise over run with that, please?
Only if you do rise on this one over run on that one, but you wouldn't really don't. That's not really how it gets done. You're confusing slope with coordinates. All right, because nothing's over anything else there. And then to get to the point 1, 4, again, that's right 1, up 4. C is at negative 1, negative 2. And D is at negative 5, 0. Now, the quiz tomorrow does not have graph paper attached to it, but if you want to use a piece of graph paper with this type of problem, you may certainly get one and use it and just attach it to your quiz. All right? There's no rule against using graph paper. Now I connect it in order so I know what my shape actually looks like. And I have to pick one of my methods for proving it's a parallelogram. Which method would you like to use? We've got proving opposite sides parallel, proving opposite sides congruent, proving diagonals bisect each other, one pair of sides are parallel and congruent. What you can't do is just, like, say, these two sides are parallel, I'm done. It's not enough. Both pairs of opposite sides have to be parallel. Both pairs of opposite sides have to be congruent. The diagonals bisect each other, or one pair of opposite sides is both parallel and congruent. Which method would you want to use? It doesn't really matter which one you choose. I've got it solved every different way in the answer key, so I know what all the right answers are. Which one would you like to choose? Pick one. Parallel. Okay, let's show parallel sides. Show parallel sides, I'm going to need to find the slope. So let's start with the slope of AB. What am I finding? Write out what I find. What I'm finding. Use the formula. Slope, change in y, 4 minus 6, over change in x, 1 minus negative 3. That's negative 2 fourths, or negative 1/2. Now, I could go to BC, then CD, then DA, or I could go straight for the opposite side right away. So I have the two grouped together, the parallel ones I hope are parallel. So I'm just going to go straight to CD, because AB has to be parallel to CD. So slope of CD. Again, I'm identifying what is it I'm finding. Set up my formula. Slope of CD. 0 minus negative 2, so 0 plus 2, over negative 5 minus negative, or negative 5 plus 1. So that's 2 over negative 4, which is negative 1/2. Aha. Parallel. I circle it. I note what I found. But that's not enough. That's one pair of sides parallel. I've got AB parallel to CD. My second choice at this point, I need to either show the other pair of sides as parallel or show that same pair of sides as congruent. I have a choice. I can go either way. So I've just shown one pair of sides are parallel. Again, I'll repeat. I could show the other pair of sides are parallel, or I could show those same sides are also congruent. Either one will work. Which one would you like to do? Other pair parallel or same sides congruent? Congruent? Okay, let's do congruent. So next thing I need to find the length of AB. So I'd write that out. AB equals, that means the length of AB, we set up our distance formula. X's are negative 3 and 1. Y's are 6 and 4. Yeah, so it's negative 4 and 2. So that's square root of 16 plus 4, which is the square root of 20, which I'm not going to bother simplifying because that's not a final answer. That's just a work in progress. And then I'd have to find, after that, length of CD. And again, I'd show my work. Don't just write CD equals the square root of 20. How? Prove it. This isn't two-column formal proof, but your work is your proof. Your work is your evidence, and I need to see the evidence. So CD, it's negative 5 and negative 1, and 0 and negative 2. So that's 4 squared plus 2 squared and negative 4 squared and 2 squared. Square root of 16 plus 4 is square root of 20. They're congruent. I indicate what I found. So since the same pair of sides is both parallel and congruent, that makes that a parallelogram. I just proven that's a parallelogram. Yes. Yeah. No. Well, I could do it by what I just did here. Show they're parallel and then show that the same sides are congruent. What's one of our theorems? One of our theorems says ABCD is a parallelogram if one pair of opposite sides is both parallel and congruent, right? This is why we need to know what the theorems say. This is why we been putting that up on the board and working with that. Just reviewing, what are the 5 ways that can prove that something's a parallelogram? Both pairs, opposite sides, parallel. Both pairs, opposite sides, congruent. Both pairs, opposite angles, congruent. Now this one, the opposite angles, we usually can't do in the coordinate plane. Okay? That's the one that gets left out in the coordinate plane because we can't prove angles that are congruent without using a lot more trig and stuff like that. One pair of sides is both parallel and congruent, or the diagonals bisect each other. Those are the 5 ways I can show that something's a parallelogram. But I have to make sure my measurements support one of those 5 reasons. Let's do it again using a different method. Negative 3, 6 is A. B is at 1, 4. C is at negative 1, negative 2. And D is at negative 5, 0. This time let's show the diagonals bisect each other. Diagonals are AC and BD, so I'd say midpoint of AC is at, and we use midpoint formula, negative 3 plus negative 1 over 2, 6 plus negative 2 over 2, which is negative 3 and negative 1 is negative 4 over 2 is negative 2. 6 plus negative 2 is positive 4, so it's positive 2. So the midpoint of this diagonal is at negative 2, 2, right about there. My drawing's off a little bit, my orientation's off of here. And I find the midpoint of the other diagonal. And again, I label, what am I finding? Find the midpoint of BD. I set up my formula, and I plug my numbers in. 1 plus negative 5 over 2, 0 plus 4 over 2. That's negative 4 over 2, that's negative 2, 2. Aha! Same midpoint, diagonals bisect each other. All done. Because they both have that same midpoint at negative 2, 2. Now, it's only 2 measurements instead of 4. That's a little nicer. I mean, it's kind of like 4 because I get 1, 2, 3, 4. But remember, when I'm finding midpoints, I'm always expressing my solution as a point because it is a midpoint. It has coordinates. It should be in parentheses to indicate it has coordinates. I know you find this kind of tedious sometimes, but learning to follow rules, learning how to use a system, learning what's expected and how you're supposed to write it up, these are all good skills. Your jobs are going to have all sorts of job functions that require you to use certain skills and write things certain ways and show evidence of this and whatever you do when you get careers. We could do it again, but I think you're kind of getting the point on this. I don't want to work it to death. If you did not do the homework last night, or you didn't complete the homework last night because you were just doing partial work or did them all the same way, remember, you had 4 problems. You're supposed to use all 4 different methods that we have. So one should have been done using this, one should be done using this, one should be done using this one. These are the 4 ways you were supposed to demonstrate. So if you didn't do that, go back and redo it tonight. I will take it for full points till tomorrow. If people got it done on time and did it correctly, you might get a bonus point. Okay? So I'll give bonus points to people who got it done correctly on time the first time. For people who did not, I'm giving you a second chance to go back and work on this. Graph papers back there, tons of it for free. Yes. You did. Because you tried all 4 ways. Yeah, some people who just need to go back and do a little bit more work. Or a couple. So, and you should know if you weren't done or if you used the same method all 4 times, something like that. Okay? You can still get full points for it. Other than that, work on your review packet. And, yeah, that's it. Unless you have questions. I apologize for the voice.